All right, today we're going to look at gas tests. When a chemical reaction takes place, we have some of our look-fors, and one of our 5 look-fors, of course, is bubbles. Is it bubbling? And if it's bubbling, that tells us that a new gas is being created. Now, what we want to do in this lab that we're going to do tomorrow is we want to identify what that gas is. The problem with identifying gases is we can't go based on their physical appearance. Gases are invisible. Look at the gas around you right now. It's air. In that air, there's nitrogen, there's oxygen, argon, carbon dioxide, lots of different things. There's also water vapor. Sometimes gases are some examples of gases that we're going to test for: oxygen, carbon dioxide, and hydrogen. So how do you know which is which? So basically what this note does is it describes the burning splint test. So burning splint is just a burning popsicle stick. And what happens is in the presence of pure oxygen, you can see in the diagram down here, if we take a burning splint that is burning and it comes into contact with pure oxygen, it will glow or burn much, much bigger and brighter and hotter. That's kind of dangerous to make a small flame bigger. So what we do is we get a popsicle stick or a splint that is on fire. We blow it out so it just has a little orange end to it, that little glowing end. And we put that into contact with oxygen gas. And what happens is it'll either glow brighter or more times than not, it'll burst back into flames. Now we know fire has 3 ingredients: heat, fuel, and oxygen. And so what we're doing here is we're adding in more oxygen to that ratio, and it's burning brighter. This is something that you'd go over if you ever did firefighter training. Firefighters always want to know what type of fire they have when they are rolling up to it. If they are rolling up to a factory that has oxygen tanks in it, perhaps for welding, they want to know that. If that flame gets too close to the oxygen and one of those canisters ruptures, suddenly you're going to have a flame way brighter, way hotter, way bigger, way more dangerous to them. So they want to know that. Likewise, going into an oxygen-rich environment like a hospital where there's oxygen cylinders and hookups for patients. Nurses in hospitals and doctors, they have to be very careful not to create static electricity. So they wear rubber-soled shoes. They're very careful of what they do. They don't want to create a little spark of static electricity around a patient that is getting 100% oxygen. It's a recipe for disaster. So oxygen has to be treated very, very carefully, especially around flame. Hydrogen is another gas, and what happens is when flame comes into contact with hydrogen, you get a pop, kind of a type of noise. And that lets you know that hydrogen gas is present. A third one is carbon dioxide, and we have 2 different tests that we do for this. The first is we take a burning splint, as the picture indicates, and when it comes into contact with carbon dioxide gas, it goes out. The carbon dioxide gas does not support combustion. It displaces all the oxygen around the fire so it can't get to the flame, and that flame then goes out. A second test we do is called a lime water test. Lime water is just some calcium carbonate and water, and the calcium carbonate is in solution, so it just looks like normal water. When carbon dioxide is introduced into that water, the lime water will go cloudy. And normally I demonstrate this for you. I will link a video. It's not part of your official lab write-up, but I will link a video so you can see that this happens. And basically what happens is baking soda and vinegar are mixed together, creates carbon dioxide gas. It's captured in a test tube, run through a little hose. The gas runs through a hose and into some lime water, and you can watch the lime water go cloudy. I'm also going to link a video that shows the Hindenburg explosion. And just to give you a little bit of background information, so the Hindenburg was a big blimp, a big airship. Now, this happened back in the, oh geez, I can't even remember the actual date. Uh, but back at the time, uh, it was hard for planes to go across the Atlantic, and they figured that at this time that blimps were going to be the future of transatlantic travel, that going back and forth between London and New York or Paris and New York, that blimps were going to be the future. So the blimps were filled with hydrogen, a lighter than air gas, which would allow them to sort of makes them float in air, and they have engines that would propel them, and they would go back and forth. In fact, a little bit of fun trivia: the Empire State Building, that needle at the top of the Empire State Building, is actually a blimp docking point. So the Empire State Building was built thinking that as these blimps or airships came across the Atlantic Ocean, that they could dock in air to the Empire State Building, and people could disembark and make their way down the stairs to street level. You'll see in the video the Hindenburg. The Hindenburg was a German Zeppelin or German blimp. And on the tail, you will see the swastika. Now, the swastika, it's actually a symbol that's several thousand years old. It's Sanskrit, and it is a symbol for peace. Ironically, in the 1930s, the Nazi Party of Germany took that swastika. They actually made a mirror image of it, which is what you're seeing. And it has now gone from a symbol of peace to a symbol that signifies so many negative things. But initially, the swastika was a symbol of peace. It then became the symbol of the Nazi Party. And the Nazi Party, after all the terrible atrocities that they did leading up to World War II and in World War II, of course, it now has a negative connotation, which is too bad. What you do see in the video, though, is the Hindenburg as it's trying to land in New Jersey, which is basically right across the Hudson River from New York City. It encounters some difficulties and it goes up in flames. It shows you that hydrogen is very, very flammable. And you can see how fast that blimp was consumed. So a little piece of history there, which I'll show you as well. If you weren't familiar with it, you now are. Not only that, what I often find interesting is just the whole tone. So this is a newscast, and the newscast of the day was much different than the newscasts of today. So a little bit more storytelling. The language in it is incredible, very descriptive, and even the use of some music. So a little bit different than tuning into Global or CTV News today, that's for sure. So that is the gas test lab using a burning splint. Tomorrow I will assign the gas test lab for you to work on.